Hey, what's up YouTube? So here I have built two more red laser devices. These are portable and rechargeable units, and each of these uses a cheap red laser diode that comes from China. I bought it off of eBay, and these lasers are often highly unregulated, and they can often exceed 20 to 30 milliwatts of output power. So these units are fairly simple to put together, and we'll go through the assembly process here, as well as some testing, and we'll see which one is more dangerous than the other. They're probably more or less the same, but anyways, this should be fun. Alright, so we'll start off with this unit right here. This unit is comprised of a power supply, the driver, as well as a circuit protection board for protecting the batteries, and here we have the laser module right here. So for the power supply, we have 3 lithium-ion cells which are configured in parallel here. So for these 2 cells right here, I removed them from an old broken laptop and recovered them back to their nominal range. As for this one, I removed it from an old broken hand drill, and again, I was able to recover it back to its nominal range using an AC to DC charger for these cells here. Lithium-ion cells are great power sources for laser diodes because they have exceptional energy density storage capabilities, as well as low operating voltage, relatively high amperage outputs. The power supply is connected in parallel to the circuit of the unit here. And here I've connected my multimeter probes in parallel with the battery supply here, and we see a voltage readout of 3.4 volts there. And here we see our other diagonal parallel connection with the probes on the power supply, and that gives us a voltage readout of 3.6 volts. So for safety purposes, I've connected in parallel this circuitry board here, which is a protection management board for the lithium-ion batteries, and this ensures that the batteries do not over-discharge, under-discharge, or over-discharge in some circumstances. So as for the driver, I'm using an LM317T adjustable voltage regulator as the semiconductor here, and I have that heat sinked. I have the positive input wire coming from the battery management board from the positive lead of the power supply to the input pin here. However, I did hack off the negative lead coming from the management board because I don't need it. I made it a lot better, and we'll go through that in a minute here. I also have an additional wire, this brown one, coming from the heatsink to the input pin, which gives me excess current that is also well regulated. 3.3 k ohm resistor, and I have the adjustable pin going to the positive output pin via that resistor, which signals to the positive signal here to the laser diode. And then as the other negative lead, I'm using this positive output lead of the power supply here directly connected to this alligator clip. So all you have to do is connect this one clip to the brass module here, and that gives us a very dangerous laser. Ergo the danger warning sign there. As for the laser module, it's really quite simple. I'm just reusing this brass housing that I got from my stock, and I have the laser diode housing, which is also made of brass, pressed in the rear here as far as I could, and it makes good thermal contact with the housing here. And yeah, this should be suitable for the next little while. And here I have the laser device powered up here. So although this laser does have the ability to have a long range in a far field, right now I have it adjusted to a converged focused point in space and time where the power is at its highest in terms of density and volume. Alright, now we can do some tests here. Alright, let's see how fast this laser can shear through some thin electrical tape. Pretty obvious there. Yep, there's the focal point. You can see whiffs of smoke coming off of the tape there. This laser could actually be a bit higher than 30 milliwatts. There you can see the holes. Let's see how fast this can cut through tape. So overall, it's a pretty cool laser. It is portable and rechargeable. It is easy to make and easy to test, with protection of course. And the laser output power is most certainly 30 milliwatts. It could actually peak a bit higher than that and then drop down at a certain point.